on geometry. And the topics we'll be doing today are definitions, shapes, perimeter, and area. But most importantly, you guys get to meet Bob, who's just amazing. Our first topic of today is the definitions. And our first definition is the most basic of them all, the point. It is also the base of all geometry. So something interesting about the point, it has no size. It's literally just a dot. And here are two examples of points. We call this one with an A, point A, and this one with a B, point B. Got T. Then we move on to our line, which is basically a collection of infinitely many points continuing on in a straight line, like this. And it extends infinitely in both directions. And the way we show that is by having two arrows at the end of this line. And we have our little letter here, which is L, and so we call that line L. Then we move on to our ray, which is basically half a line. It's like we take this line and cut it in half, and we get it, ray AB. And it only extends in one direction, so we have one arrow. And lastly, we have our line segment, which is basically a connection of 2 points. And it's a part of a line. And we call this line segment AB. Now on to more definitions. We start off with angles. Angles are basically two rays together. This is a ray and this is a ray. And they all have a degree measure, which is basically saying how far apart each of the rays are. And we have 3 types of angles. We have obtuse, acute, and ray. Obtuse angles look like this. When you're going to eat food and your mouth is wide open because you want food, that's an obtuse angle. And it means that the degree measure is more than 90 degrees, meaning the rays are more than 90 degrees apart. Then we have our acute angles, which is basically how your mouth is when your mom is trying to feed you bad veggies that you don't like. And so it's like this. And you're trying to close it, but you're not closing it yet because you want to hurt her. Anyways, so they have a degree measure of less than 90 degrees. The rays are less than 90 degrees apart. And lastly, we have our right angles, which is exactly 90 degrees. And it's basically like this. One straight up here, one straight down here. And it's basically like the connection between 2 walls. And you show it with a little square thing. Another example of how a right angle looks is an L. An L has a right angle. Then we have our planes. Planes are basically flat regions, like a wall, a cover-up textbook, the phone screen you're watching this on, or laptop, never know. And there are 2 dimensions, length and width. For example, this whiteboard, this is the length, and this is the width. This whiteboard is a plane. And there are many types of planes, like a lot, and here are some different types of examples. We have a square, triangle, circle, trapezoid, parallelogram, and more on those types later. And now let's move on to our second topic, which are shapes. And we start off with the smallest shape we have, which is the triangle. And it only has 3 sides. So a triangle is a lot like the upper part of an A. In fact, the upper part of an A is a triangle right here. And one cool thing about a triangle is it has 3 angles and they all add up to 180 degrees. So that means this plus this plus this equals 180. So let's try doing a little problem. If all of these add up to 180 and this is 50 and this is 50, what is this? Well, let's do a little math. We do 180 minus 50, which is 180 minus 100, which is equal to 80 degrees. Therefore, this is 80 degrees. And quick pop quiz, what kind of angle is an 80-degree angle? If you said acute angle, you're right. It's an acute angle. That's because 80 is less than 90. Moving on. We then have lots of different shapes that are all called quadrilaterals. And these quadrilaterals are basically any kind of shape that has four sides. And another cool thing about a quadrilateral is that all of its angles add up to 360. So here are some examples of quadrilaterals. We start off with our square. This is a square. All sides are equal. So this, and this, they all have the same length. I just suck at drawing, so it might be a bit hard to see. Anyways, so if this is 4 units, this is 4, this is 4, and this is 4. Cool. And then its opposite sides are parallel. So this is parallel to this, and this is parallel to this. If you don't know what that is, here's a quick review. Parallel lines. These parallel lines are 2 or more lines that never meet. For example, think of the things along a railroad track, and they look a lot like this. And then we have perpendicular lines. They form a right angle, like this. And think of it as if you have a wall here and a wall here. These walls are technically perpendicular lines. Back to our square. These two sides are parallel, and these two sides are parallel. And they have 4 right angles. What are right angles? If you said that they have 90 degrees, you're right. They each have 90 degrees, and they're all equal. And since a square is a quadrilateral, 90 plus 90 plus 90 plus 90 is 360. And guess what? That's the total angle measured in a quadrilateral. So there you have it, a square. Moving on to more shapes. All 3 of these are more quadrilaterals, so they all add up to 360 degrees. So we start off with our rhombus. And in a rhombus, all of its side lengths are equal. So it's like a square, but not necessarily. And then our opposite sides are also parallel. So this is parallel to this, and this is parallel to this. But this is equal to this, which is equal to this, which is equal to this. So that means if this side is 4 units, all 4 of those sides are also 4 units. And then we have our parallelogram. Parallelogram looks like this. And its opposite sides are equal. So this is equal to this, and this is equal to this. But however, this is equal to this side. And its opposite sides are also parallel. This is parallel to this, and this is parallel to this. Then we have our rectangle. The rectangle is probably the most common shape you see every day. It is like the screen you're watching this on, whether you're watching it on a TV, a phone, or a laptop. Most of those have rectangular screens. And so, in a rectangle, opposite sides are equal, so this is equal to this, and this is equal to this. Opposite sides are also parallel. This is parallel to this, this is parallel to this, and there are 4 right angles. Pop quiz. Again, how many degrees are in a right angle? If you said 90, you're right. Haha, right. So, each of these are 90 degrees, and 90 plus 90 plus 90 plus 90 is equal to 360, which is the number of all degrees in a quadrilateral. And one last thing. If you guys are confused about these markings, this is what it means. So if you see a straight line like that across the side, that means all the sides that also have that marking are equal to it. So this thing has 1, 1, 1, 1. All sides are equal. And then we have these arrows. If there's 2 arrows, that means the other lines with 2 arrows are parallel to that first line. If there's 1 arrow, all the other lines with 1 arrow are parallel to that 1 arrowed line. So 2 arrow, 2 arrow. These are parallel. 1 line, 1 line. These are equal. 1 arrow, 1 arrow. These are parallel. 2 lines, 2 lines. These are equal. And so on. Now for our last 2 shapes, which is the trapezoid, which is, guess what? Another quadrilateral. And if you want to know why, look, 1, 2, 3, 4 sides. And one cool thing about a trapezoid, it has only 1 pair of parallel sides, and that is this right here. These 2 sides are parallel, and they are called our bases. Now we move on to a circle. A circle is basically the collection of all points that are at a set distance from another point. So let's say this is my center point, and this right here is the distance. Everywhere the tip of my finger touches forms a circle. It's not going to be completely good, but close enough. And so that set distance is called our radius. Anyways, so here's a circle, and this everywhere in blue is the actual circle. And in that curve of blue are infinitely many points that are the same distance from the center point up. So this is the same distance from O as this, and this. So here's where you can find a common circle. Maybe the camera thing on the back of your phone. It's usually shaped in a circle. The lens on a camera is also in the shape of a circle. Many lights are in the shape of a circle. And most importantly, the sun. Whenever you look at it, don't look at it for too long or just don't look at it directly at all, is in the shape of a circle. So here you see my beautiful drawing, which should be sold on eBay for $1 million, is the grass, the sky, and whenever you look at the sun, which is probably not orange, a circle. So now let's move on to our second to last topic, perimeter. And so, what is perimeter? Let's use an example to show you what perimeter is. Let's say I want to find this weird blob thing is Agora Hills. And we want to find the perimeter of Agora Hills. So what we're going to do is we're going to take our trusty assistant / stick figure Bob, who is amazing, and we're going to take Bob, we're going to make him walk all the way around the outside of Agora Hills. And that way, we find the perimeter. So, using that, what can we say is perimeter? Well, perimeter is basically the distance around an object. Yay! So let's try an example right now. So, I have some string, a ruler, and an eraser. We're going to put the ruler aside for now. And we're going to take the string. This is going to be used for perimeter. I got my eraser back. And we're going to take our string, wrap it around to find our perimeter. So that's how long the perimeter is. So now let's measure it. So I'm going to take the ruler, which I dropped again, and by magic, I'm going to get it back. Ta-da! And we're going to measure it. And when we measure it, we get that it's 30 centimeters. So therefore, the perimeter of my whiteboard eraser is 30 centimeters. Ta-da! So now let's try some examples for perimeter. And we'll start off with the triangle. In this triangle, we have 4 centimeters, 3 centimeters, and 5 centimeters. And we want to find the perimeter. So once again, we're going to use our trusty assistant Bob, and we're going to start from here and see how long it takes to go around. So Bob first walks around this, which is 4 centimeters. Then he decides to walk up, which is 3 centimeters. And then he walks back down again, which is 5 centimeters. So now let's add this up. 4 plus 3 is 7. 7 plus 5 is 12. Therefore, our perimeter is 12 centimeters. Thank you, Bob. Now, let's try the square. So we're going to use some things that we learned before, because in this, annoyingly, the problem only gave us this side length. But then we're going to be like, oh wait, we're smart. All the sides in a square are equal. So we know that this is 4 centimeters, this is 4 centimeters, and this is also 4 centimeters. So we're going to take Bob once again. We're going to start here, go down, turn, go up, and back to get 4 centimeters plus 4 centimeters plus 4 centimeters plus 4 centimeters, forgot the M, equals 16 centimeters. Yay! And then we have a rectangle. The problem, guess what, is annoying. So it decided to only give us 3 centimeters and 4 centimeters. But we're going to use what we learned before to know that opposite sides are equal in a rectangle. So 4 centimeters, this is also 4 centimeters. And if this is 3 centimeters, this is also 3 centimeters. So Bob, once again, we're going to make you do physical labor for us learning. 3 plus 4 plus 3 plus 4. Let's write that down. 3 plus 4 is 7, plus another 3 plus 4 is 7, which is 14 centimeters. But wait, you might be wondering, oh, this is going to take forever. What if I have a giant problem? Well, we're going to have some formulas. Yay! So I hid these for now so you guys don't take a shortcut into trying these. Let's uncover it. For a square, if we only have a side length, all we do is do 4 times that side length. For example, in this, the side length was 4. We multiply it by 4. We get 4 times 4, which is 16 centimeters. Yay, it works! Now let's use our rectangle. Our rectangle's formula is basically adding the length and the width, multiplying it by 2. We add the length and the width. 3 plus 4 is 7, times 2 is 14. It works. And now for the last topic of today, area. Yay! So basically, area is how many tiny squares can you fit in an object, or at least that's how I think of it. So let's try to figure out area as we do this. So if we try to figure out how many little squares we can fit in this, let's make this a rectangle. Let's extend this. So this is 3 and this is 4. And then we're going to draw our mini squares. Since this is 4, there's going to be 1, 2, 3, 4, and this is 3, 1, 2, 3. Yay! So basically, we can see that this triangle is exactly half of this rectangle, which is cool. So we're going to count how many squares are in the entire rectangle, and then we're going to divide it by 2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 squares in the entire rectangle. We're going to divide that by 2 because a rectangle, if you cut a rectangle in half, you get a triangle. So 12 divided by 2 is equal to 6, meaning the area for this is 6. And then we're going to move on to our square. So the square, as we know before, this is also going to be 4 because all sides in the square are equal. So we're going to split this into 4 parts. We're going to split this into 4 parts. And when we do that, we see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16 squares. That means our area is 16 because there's 16 little squares. And then we have our rectangle. So we're going to cut it in 3, and 1, 2, 3. And we're going to count the number of squares. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yay! That's the area. But I'm pretty sure you guys are going to be like, ugh, do I have to do this every single time? Well, if I had to do this every single time, I would be like, ugh. So instead, we have amazing formulas. Yay! And I just kept Bob up there because Bob is amazing, and I'm too lazy to erase him. Anyways, so our formulas for a triangle. You take the base times the height divided by 2, or multiply 1/2. So basically in this, the base is 4, the height is 3. 3 times 4 is 12, divided by 2 is 6. And that was our area. For a square, all you have to do is take your side length and square it. And if you guys don't remember what squaring is, it means you're multiplying it, whatever you're squaring, by itself. For example, we have our square. You have the side length of 4. 4 squared is 4 times 4, which is 16. That works. Yay! And last but not least, we have our rectangle. Length times width. Length times width. 3 times 4 is 12. It works. Yay! Don't forget to subscribe and like. If you have any questions, you can email info@agoramatrical.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So